This lesson is continuing the last one on the rules for significant figures. We will be doing examples of these in class, so I'm not expecting you to master the whole thing just from going over these notes, but it's an introduction that you can hear it as many times as you need to, and then when we work on it in class, we'll make sure that you master it. In the last segment, we were talking about how to round some numbers to 3 significant figures. We picked 3 as an arbitrary number, but it's pretty common to work with. We discussed that you would round 26.54 to 26.5 because the 4 isn't great enough to make the 5 round up. We talked about 2.769 would round to 2.77, or I don't know if we said the final answer, but that's what it would be because this 9 was bigger than 5, so it makes this 6 round up. So 2.77 would be 3 significant figures. If we come down here to the next one, 6.0209, mark off 3 figures, and then you consider the 0. Well, the 0 is not big enough to make the 2 round up, so 6.02. Where it can get kind of tricky is right here with this one, 770.33. If I want to box off 3 significant figures, and I look at the 3 here, and the 3 is not big enough to make the 0 round up, but if I write 770, just like this, then that's only 2 significant figures because the 7's in front count for rule number 1, non-zero numbers. The 0 at the end doesn't count as significant because you can't see the decimal. But I want it to be 770 with 3 significant figures. So I have 2 options. I actually have 3 choices. One is I could put the decimal down and write the decimal in there. It doesn't change the magnitude of the number, but it changes how many significant figures that counts as. Now it's 3, just because you can see the decimal written there. Another choice I have is I could write a bar above the 0. It looks sort of like a repeating sign, but it doesn't mean repeat. In this case, it just means this 0 is significant. So I could write 770 with the bar over the 0, or I could write 770 decimal, or I could write it in scientific notation, in which case it would be 7 point, oh, come on, point, 70, be nice if I had a pen pad, times 10, well, I ran out of screen room there. It would be times 10 to the what? Well, I moved my decimal over 2 places, so times 10 squared. So 7.70 times 10 to the second. And all 3 of those ways are ways to make that number into 3 significant digits. Well, what about here? Block off the first 3. Will that 7 make the 1 want to round up? Will it round up? Yes. But when I put in a 1 here, remember, I can't leave these places off. Imagine if this was my bank account. I don't want to go from almost $250,000, let's say, over $200,000 down to $220. So you have to make sure that you fill in these places with zeros. So it would be 221,000, 221,000. And then on the bottom one, I need 3 SigFigs. Well, do you remember our rules? The zeros in the front don't count. So to get 3 significant digits, I have to start with the 4. 4, 5, 2. Now look at the 5. That makes the 2 round up to 0.453. Now again, if you were going to take physics, the rules are a little different, and if you get way into super fancy SigFig rules, there are some more advanced skills, but for what we're doing, these are going to be sufficient for what we're doing. So there's the answers to our last set. This should have 3 more zeros over here. Sorry about that. Now, when we multiply and divide using significant figures, the rules are different than when you add and subtract. When you multiply and divide, we round the final answer to the fewest number of SigFigs in the problem. Here's the same rule in case you didn't get it before, or you can rewind and go back and write that again. When we multiply, we round to the fewest number of SigFigs in the problem. Okay, so let's say you're going to multiply two measurements of meters to find an area. So 7.55 meters times 0.34 meters. Well, you're going to stick it in your calculator, and your calculator is going to tell you something. But remember, your calculator doesn't know SigFigs. So here's what we do. We say, how many significant figures are in 7.55? Well, those are all non-zero numbers, right? So that's 3. 3 significant figures there. In 0.34, how many SigFigs are here? That's 2, because the 0 in front doesn't count as significant. So between 3 and 2, which is less? 2. So that means you need to have 2 significant digits in your final answer. So you put it in your calculator and you calculate. And your calculator says 2.567 and you add square meters. But this is 4 SigFigs, not 2. So what do? Well, that's when you round off. So we need to round to 2 SigFigs, so we block off the 2.5, and that 6 right there tells me that this 5 rounds up. So my final answer is going to be 2.6 square meters, because that's the answer that has 2 SigFigs in it. When I add and subtract with significant figures, the rules are different. This time we round our final answer to the fewest number of decimal places in the problem. It's not really decimals because you can only have one decimal, but the fewest number of decimal places in the problem. For example, if I want to add these measurements together to get, let's say, a perimeter, well, the total is 27.37 according to my calculator, but my calculator doesn't know SigFigs. So what I have to do this time is look at how many decimal places there are. 2.1 is in the tenths place, so that's only one decimal place. 24.03 is 2 decimal places, and 1.24 is 2 decimal places. So between 1, 2, and 2, 1 is the fewest. So that means I have to round off my answer to 1 decimal place. So that means I block off my 1 decimal place and I look to the right. Is it 5 or more? So what do I do to the 3? So the answer is 27.4 meters. In our next lesson, we'll be learning about dimensional analysis, but I'll put that on another video, and we'll do lots of practice in class. If you haven't already seen all the lessons on significant digits, accuracy and precision, scientific notation, you need to make sure you go back and watch those.